In this lesson, we're going to be talking about graphing with systems of equations, and specifically we're going to be looking at the number of solutions. So by the end of this lesson, you should be able to determine if there is one solution, no solution, or infinite solutions from a graph. When we talk about systems of equations are when there's two or more equations that can represent a situation. We use system of equations to solve many different problems, such as the one that we see here. We see that tickets for a concert are $40 for main floor seats and $25 for upper level seats. We know that there was a total of 2,000 tickets that were sold, and we know the total sales, the amount of money earned, was $62,000. What we don't know, however, is how many of each kind of ticket was sold. So these types of problems are helpful because if we can figure out how many of each type of tickets were sold, then we can better market and figure out how to price the tickets accordingly. So what we would need to do here is set up two different equations. This is called the systems of equations. So we have two different totals that they give us. We know that there were 2,000 tickets that were sold, and we know that the total sales were $62,000. So we would define our variables here. That would be the first step that we would want to do. So I'm going to make X number of upper level seats. Actually, I'll make X the number of main floor seats since that's what came first. So main floor seats. We'll make Y the number of upper level seats. Alright, so we know that there were a total of 2,000 tickets sold. So the number of main floor seats, X, plus the number of upper level seats, Y, should be equal to $2,000. So that would be our first equation. Our second equation has to do with the value. So I know that each main floor seat was $40, so $40 times the number of main floor seats that were sold, plus $25 times the number of upper level seats that were sold, should give us a total of $62,000. So now that we have the two equations, we could solve them using a systems of equations. You could graph them. We could use a method known as substitution, or we could use a method known as elimination in order to get the solution here. When we're graphing systems of equations, there are, again, this is when we have two or more equations. The solution to any systems of equations problem is going to be an ordered pair that satisfies both equations. So it's going to be a point that is on both lines. We could have, when we're graphing systems of equations, we could have one solution. That's where the lines intersect at one point, so their slopes will be different. We could have where there's infinite solutions, and what you'll notice for this one is that the lines are the same. It ends up being the same exact line for both. And so if it's the same line, then they share all of the same points in common. So that's why we call it infinite solutions. Or we could have no solution, and this is when our lines are parallel. So they would have the same slopes, but at different y-intercepts. They would never intersect, meaning they would never have a point where they're equal. Okay, so let's look at the following situation. So here we have two lines. We have y equals x minus 7. So this one would say, let's start at negative 7. All right. And then it has a slope of positive 1. So I would have my slope of positive 1. I would graph my line, my points, up 1 over 1. When we're graphing with systems, you want to make sure that you get all of your lines, or all of your as many points on there as possible, so that we can clearly see where they intersect. Our second one starts at negative 2. And it has a slope of negative 1/4. So we go down 1 and right 4, down 1 and right 4. Or you could go up and to the left. Remember, we want as many points as possible. So again, once I have that, then I can draw my line to those points. So I would describe these lines as they are intersecting. Their slopes are different. And do they intersect? Yes. And we know that they intersect at the point 4, -3. And so that would be the specific solution here. So this has one solution. If we look at the next one, we see that we have y equals 3x plus 5. So this says start at 5 and has a slope of 3. So it says go up 3 and over 1, or go down 3 and back 1. Again, our goal is to get as many points as possible. We want to graph our next one. In order to do that, though, I'm going to have to change this to slope-intercept. So add 3x to both sides. We get y equals 3x minus 4. So this one starts at minus 4. It also has a slope of 3. What you might notice on this one, get that point right. You might notice that these lines happen to be parallel. So remember that if they're parallel, that they have the same slopes. And do these lines intersect? No. So we would say this has no solution. In this last example, we have two lines. One's in point slope form, one's in standard form. And we need to graph them in order to determine how many solutions there are. So we're going to graph them on the same grid. Now, for the one that's in point slope form, I don't have to change it because I can graph directly from point slope form. I would just need to pull the point. So the point from here is is positive 2. Remember, we don't include the minus sign here. And -3. If it's plus, remember that changes it to a negative. So the point that I'm pulling from here is 2, -3. So I go up to 2, I go down to -3. So go over 2, go down to -3. There's my point. Okay, and then my slope here is -2. So this says go down 2 and right 1. Down 2, right 1. Down 2, right 1. Or to go up 2 and left 1. Okay, so we got my points. Remember, we want to graph as many points as possible. Oh, there's my line. All right, and now I want to change. Now I'm going to have to change this next one because I can only get 2 points from here the way that it's set up right now. And again, we want as many points as possible so that we can see where and when they intersect. So start by subtracting 4x on both sides. This will give me 2y equals -4x plus 2. Divide both sides, everything by 2. This would change to y equals -2x plus 1. So this one wants me to start at 1. And it has a slope of -2. So what I notice as I'm graphing this is that these two equations represent the same line. So what would I say about these two lines? I would describe them as being the same. The slopes are also the same, right? Same slope and same y-intercept. And so do these lines intersect? They do intersect, and they intersect everywhere. So yes, at all points. So this would be infinite solutions when it's the same line. Before watching the next video, what I would like for you to consider is the difference between one solution, infinite solutions, and no solutions when we're looking at a graph.